Dr. Gomathi, working as an assistant professor in the Department of Chemistry. Today I am going to present the topic symmetry elements and its operation. First we are going to see what is meant by symmetry. So symmetry is a certain part or a portion of an object looks exactly like another part. So symmetry is when the shape looks identical to its original. Okay, so for example the pictures are given here. So this picture is showing a symmetry and this is an asymmetry. So symmetry is the thing when we cut the portion, when we cut the object into two equal half, one half will be identical to the another. It is called as an symmetry. When it is dissimilar means it is called as an asymmetry. Usually nature allows symmetry. Most objects found in the nature will have symmetry. So symmetry is associated with beauty. So the symmetry of a molecule reveals about the information of the properties of a molecule like its structure, spectra, polarity, chirality and so on. Clearly we can define symmetry as with the example linear molecule ABA is different from AAB because the bond of AB is not equivalent in AAB, which is equivalent in ABA. So this is a example for a symmetry where nature gives a symmetry to this. So first example is a butterfly. So when we cut the plane here, this half will be the mirror image of this. This is also the tree which is revealing the symmetry, the flower and so on. So simply we can say that symmetry is a self-similarity. So the shapes will have a similarity when we cut the shapes into the, here means one half will be the mirror image of the another half. So the symmetry can be used to construct bonding based on the atomic orbital and classify the molecular orbital. It is used to predict the Raman spectroscopy and IR spectroscopy. We can access the reaction pathway through which the mechanism can be processed, and it is used to classify the electronic rotational, vibration and nuclear spin functions, and it is used to find out the allowed state and the forbidden state, and we can predict the physical properties and selection rule using the symmetry. So next is the symmetry elements. We can call the symmetry element as a geometrical entity such as line, plane or a point about which we can perform the operation like rotation, reflection or inversion. It is called as a symmetry element. So there are 5 types of symmetry elements. Okay, so the first one is identity, which is denoted by the symbol E, and axis of symmetry, which is denoted by the symbol Cn, and the plane of symmetry is sigma, center of symmetry is I, and improper axis of symmetry is Sn. So next we are going to see about the symmetry operation. So the operation is the movement of a molecule or object such that the resulting configuration is indistinguishable from the original. That is, when we perform the operation, after performing the operation, the resulting product will be similar to the original one. It is called as an indistinguishable configuration. So each operation will be performed related to the point, line or a plane. That is called as an symmetry element. The point, line or a plane is called as an symmetry element. Okay, so during the symmetry operation, to get the indistinguishable structure, there should be at least one point in the molecule to be unchanged. Okay, that point is called as a center of gravity. While we performing the translation motion, so translation is a bodily movement. When we transform from one place to another place, the center of symmetry will change. The center of gravity will change. Therefore, translation will not come under the symmetry operations. Therefore, the symmetry operation is the thing while performing the operation, the molecule should give the equivalent or identical configuration. So this is an example while doing a rotation, while we passing the axis here and rotating a molecule, the displacement of a molecule will be there, but the position of a molecule will not change. Therefore, after performing the rotation, the molecule will be indistinguishable. So this is an example for a mirror plane. So when we place a mirror, this is a mirror image of this. Therefore, these two are indistinguishable or identical. So based on the symmetry operation, the 5 basic operation which leaves the center of gravity are given here, that is taken as a symmetry element, and its respective operations are given in a table. E is an identity. Identity means the operation is doing nothing. Just we have to view the molecule without doing anything is called as an symmetry operation for identity. And for proper axis of rotation, rotation is the operation. Okay. So for mirror plane or plane of symmetry, reflection is the operation, and for center of symmetry, inversion is the operation, and for improper axis of symmetry, rotation followed by reflection is an operation. First we are going to see about an identity. So identity, we already seen that the operation does nothing. It has no effect. So it is the simplest of all the symmetry operation. All the molecules or the object possess the operation identity, and it is denoted by a symbol E. We know the multiplication table. So in multiplication table, 1 is a number in which we are multiplying the other number. It doesn't change that number. Similarly, E has the same importance as a number 1 does in a multiplication table, and E is the identity operation which can generate only 1. Next one is an axis of symmetry. So the axis of symmetry is a rotation of a molecule about an axis through some angle results in a configuration which is indistinguishable from the original. Then the molecule is said to have a proper axis of symmetry. Okay, so the proper axis of rotation is Cn, where C stands for cyclic and N stands for order of symmetry axis. How can we find the order? Means by doing a 360 degree by N, we can able to find out the N fold of rotation. For example, if you are getting a structure, indistinguishable structure 2 times means, then it is called as an C2. So the degree is 180 degree rotation. If it is 3 times means it is 120, 4 times means it is 90, and so on. Okay, so if in a molecule 2 proper axis of symmetry is there, means the highest order is taken as a major axis. Similarly, when the x-axis which passes through the largest number of atoms is taken as a major axis. That is taken as an z-axis. So for example, the water molecule is given here. Look at here, this is a water molecule. Here the oxygen, here the oxygen will present. This is one hydrogen and this is another hydrogen. For the rotational axis, we will put the axis here. Okay, so while performing the 180 degree rotation, during 180 degree, this hydrogen will comes here like this. So this is a 180 degree operation. So while performing the 180 degree operation, the structure 1 and 2 will be equivalent. And again doing a 180 degree rotation, we will get another structure where 2 and 3 are equivalent, but on comparing 1 and 3, they are identical. Look at here, for our convenience, we are labeling hydrogen as 1 and 2. While performing 360 degree rotation, we are getting the hydrogen in a same place. This is called as a proper axis of symmetry. Okay, so this is the molecule which is having a C2 axis, and this is another example, ammonia, which is having a C3 axis. Next we are going to see about the plane of symmetry. So the plane of symmetry is a imaginary plane which divides a molecule into 2 identical halves. So this is a water molecule. When we cut the plane here, this part will be the mirror image of this. It is called as a plane of symmetry. and the plane of symmetry, the operation is reflection. It is denoted by a symbol sigma. If the plane is parallel to the major axis, if the plane which is parallel to the major axis means it is called as a vertical plane, and if the plane is perpendicular to the major axis means it is called as a horizontal plane, and if the plane is parallel to the principal axis of rotation but bisects an angle between the two C2 axes means it is called as a dihedral plane. Okay, so this is the example which I explained before. And the plane, we know that we are having three axes, three Cartesian coordinates x, y and z. Okay, so depending upon the Cartesian coordinates we can differentiate the plane like this. So this is an xy plane, this is an xz plane, and this is a yz plane. So xy plane is a plane. This is an x-axis. X-axis is like this, and z-axis is like this, whereas y-axis is like this. Okay, so xy plane means we are placing the plane here, and xz means when we place the plane like this means in the plane means it is an xz, and this will be yz. Next we are going to see about an inversion center. So the inversion center is a line drawn through a point in a molecule and extended in a both direction. It encounters the equivalent point means it is called as then the molecule is possess a center of symmetry. So it is denoted by a symbol I. Okay, so this is a molecule which is having a center of symmetry. Here we are putting a point here, and we are extending the point this side and in the opposite side. So in both sides, at the end of the point there is a chlorine molecule. So if this is the case means then we can call that the molecule is having a center of symmetry. So next one is an improper axis of symmetry, which is also called as an rotational reflection axis or alternating axis of symmetry. So it can be told that suppose a molecule is rotated about an axis through some angle and the resulting configuration is reflected in a plane perpendicular to this axis means then if the new configuration which we arrived is similar to the original means it is called as an then the molecule is possessing a improper axis of symmetry. So this is the example for this. We are taking trans dichloroethylene. Okay. So we are this is a major axis. So we are putting a major axis here. So while rotating it to 180 degree, this chlorine comes here and this hydrogen goes up. So this is the configuration which is a resultant of a rotation. And then we are keeping the plane here which is perpendicular to the major axis. We are keeping the plane here. So on reflection we are getting the structure like this, and on comparing 1 and 3 both are indistinguishable. So this is an example for improper axis of symmetry. So when the rotation is followed by the reflection and the resulting configuration is indistinguishable with the original one means then the molecule is having a improper axis of symmetry. Thank you.